Unit 6 review. Match each generic form with its correct name. So these are just the 3 different formats of quadratic functions we've seen. This is the first one that we learned. We learned this second one, and then finally the third one. So the first one, if you remember, is in vertex form. We have the h and the k, which tells us exactly where vertex is at. The next one is factored form. And then finally, we get standard form when we multiply these two out, and we write it in the highest exponent value first. So x squared, x1, x to 0. So the top one is vertex. Move that to vertex. Now the top one went to factor, so we move that down to factored, and standard form jumps up to the last option. Now they are all in the correct order. Place the correct description for each value seen in vertex form. So horizontal shift to the right when this value is positive. Horizontal only works with the h. Vertical stretch if value is greater. So stretch greater than 1 or less than -1. So when it's stretching, we're changing our a value. That's the number out in front. Okay, we're in vertex form. We're in this one right here. So a, h, and k. Reflect across x-axis if negative. So when it reflects, that's the a in front. The value is opposite of what is seen in the equation. Remember, that's the x minus h part. So it's h again. Horizontal shift to the left. This is just the opposite of the other one that we have. Vertical compression. So compression and stretch are opposite. That goes with the a. And vertical shift up, vertical shift down, these are both our k's. Which parabola is the graph of the following equation? So we have a negative sign up front, so it's going to be upside down. So that one's wrong, and that one's wrong. And we have a vertex of -7, 3. So this one's +7 and 3. This is -7 and 3. So that's correct. The answer is C. Graph the equation. All right, so concavity, it's up. Vertex is -3, comma, -5. Our parent times a, so remember our parents are 1, 3, 5, 7. 1, 3, 5, 7. And our a in all of these is 2. 1 times 2, 3 times 2, times 2, and we'll probably not even use this one down here, but, and our answers here is 2, 3 times 2 is 6, 10, and finally 14. So let's graph our vertex. I'm going to open up a bit, we'll make it a little bit brighter too. So our vertex is -3, 5. I'm going to go down first. 1, 2, 3, 4, 5. 1, 2, 3. So boom. Let me get my bigger. There we go. That's our vertex. And now remember these numbers here, we go over 1 and we're going up that number. So over 1, up 2. And over 1, up 6. 1, 2, 3, 4, 5, 6. And then the same thing on the other side. It's symmetric. So boom and boom. Now let's connect our dots. Make my line a little bit smaller. Change the font just a little bit. It's not a great line, but it should be going through that dot. It's not, but it's close enough. There we go. Number 5, for the steps that are necessary to write an equation of a quadratic in vertex form from a graph into the correct order. So, let's see here. Write the equation with values for a, h, and k. Identify one point, identify the vertex. So we're going to first write an equation. Actually, let's substitute. Sorry, I said write the equation with the values for a, h, and k. That's actually the last step. That's when we have all the values. We already have the generic equation set up. So we have a generic equation set up. We need to substitute at some point the a, k, h, k, x, and y into the equation. We don't know those yet. Once we find them, identify the vertex, identify one point. So we have h and k, x and y. Then we substitute those values into the equation. We then solve for a, and then we finally write the equation with values for a, h, and k. So that was a little challenging. And technically, these top two could go really either way. So now we're going to actually do an equation. So remember, our generic equation is down here. And we're going to find y, h, k, and x and solve for a. So our h and k is our vertex. So our vertex here looks like it's at -1, -2, and down to -6. So our vertex is -2, and should change my color. That's hard to see. -6. No, change back. -2. Now it's going to be x minus -2, so it's actually going to be turning to +2. Don't forget that part. And then we have to identify our y-intercept if we can. If we don't have a y-intercept, you can identify any other point, really. That'll work. And so the y-intercept here is 0, +2. So 0 goes in for our x, and +2 goes here. And now we're going to solve for a. Okay, so I wrote the problem on my whiteboard over here. So I'm going to go and solve for a now. So 0 plus 2 is 2. This is 0 minus -2, but that 2 double negatives turns to a positive. So a times 2 squared minus 6 equal to 2. 2 squared is 4. So a times 4 minus 6 is equal to 2. To solve for a, we have to move the subtraction problem, or the subtraction first. So add 6, add 6. 8 is equal to a times 4. So what's our a? It's 2. 2 times 4 equals a. 8. So let's go back to our question. So it's y equals, I forgot my a up front. Our a is 2, remember? X plus 2, double negative, squared, and it's minus 6. Okay, next question. We're doing a pattern here. Okay, you can do all these steps if you want, or you can go and just look at the image and see what's happening. Well, we have a little guy out here. That's our +1. Okay, so y equals something times something plus 1. Well, it's a square, so it's just going to be squared. And we can see from the very beginning of the first step, it's 2, then it's 3, then it's 4. So it's counting up one time each time, and we start with one additional block. So it's x plus 1 squared plus 1. Complete the table, write an equation in factored form. So this first one, we don't really know. It's 0 times something. So I'm going to do 0 times x. The next one, it could be 2 times 5 or 10 times 1. So 2 times 5, 10 times 1, 22. It could be 2 times 11. It could be, so 2 times 11, or it could be 22 times 1. So it's not going to be 10 times 1, 22 times 1, but we can see this 10 times 1, 2 times 11 pattern developing. 1 and 2, 10 and 11. So 3 times what equals 36? Well, it's 3 times 12. So here's our pattern. Next one's going to be what? 4 times 13. 4 times 13. 2 times 13 is 26. 26 times 2 is 52. So our equation, y is equal to 2 factors. Well, the first one is 10 and 1. So how do we get 2? So how do we get 1 from 2? It's x minus 1. And we get 10 from 2 by doing x plus 8. And these could be either order. Okay, so now we're going to match key features. The mirror line of the parabola x equals p plus q over 2, or x equals h. That's our axis of symmetry. So we'll move that one down to axis symmetry. Substitute the axis symmetry value into the original equation and solve for h and k. That's getting our vertex. This is where the parabola crosses the y-axis. Substitute 0 for x. Y-intercept. Y-axis, y-intercept. This is where the parabola crosses the x-axis. These are x-intercepts. And finally, if this is true, then we're good. If a is positive, then the parabola is up. That's concavity. If a is negative, then the parabola is down. Concavity. We are good there. Number 10, identify the key features and graph the parabola. So y-intercept we know by adding 0 into the equation. So if we put in 0 here and 0 here, we get -1 times 4, which is -4. And -4 times 2 is -8. So our y-intercept is 0, -8. Our x-intercepts come right here from the middle. We're going to have +1 and -4. Axis of symmetry is the number in between these two. So the number between -4 and 1. We can add those up and divide in half, which is -3 over 2, which equals -1.5. And our vertex we put into this problem, and then we solve. So instead of 0, we have -1.5 and -1.5. So -1.5 minus 1 is -2.5. And -1.5 plus 4 is +2.5. So -2.5 times +2.5, I know is -6.25, which you can put in the calculator if you don't know that. And all this times 2, which would equal -12.5. Now let's graph it. Get a little bit bigger pen. So we have a y-intercept at 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. X-intercept of 1, 0. So 1 is here. 1, 2, 3, 4. And our vertex, I never actually officially wrote it down, but it's way too big, is -1.5, comma, -12.5. So -1.5 is here, and -12.5. So this is 8, 9, 10, 11, 12.5. Boom. Oh, I made it wrong. Shoot. So I think it was right here, I said. Yeah. Now we're going to connect our dots. The big line. And boom.